So that means we will have a sender and a receiver. So in between, we should have a medium. Basically, you can transmit data from one end to the other end. So when you say data from other end, so we are using different technologies. So those are the things that we will discuss under data communication. So when you look at kind of a model of communication, then there will be three parts. So we'll have sender, we will have receiver, and then we have a transmission system or the medium, right? So when you talk about these, few things we discuss. Send is the one who generates the data, and then it will transmit through this. And then receiver will receive the transmitted data, right? And then transmission system is responsible for sending data from sender to the receiver. Now, let's say you are taking a phone call to your friend. So the sender is you and the receiver is your friend. And then the system is you are using a telephone system, right? Let's assume that is a wired connection like telecom. So if that is the case, so that will be the transmission system. Now for that, now remember when we have sender and receiver, especially in computing, right? The sender and receiver are some devices, right? Simply you can think of it as like two computers. So it could be two computers. So the sender is also computer, receiver is also computer. Now, when device to device communication is there, right, we have to have a set of rules which govern this communication. And for that, we call a protocol. So protocol means this defines a set of rules how a communication happens, right? So we will discuss this later on in more detail, but for the time being, you can remember the protocol as a set of rules which govern this transmission. And then we send the details as messages. So the data you send from source to destination, we call it's the message. Now, the next thing that we have actually discussed is signals. You know that when it comes to transmit, you are transmitting signals. So when you talk about the signal, there are two types. We have analog signals, we have digital signals. Now, signal could be like a voltage or a current, right? Something may vary with the time, right? Now, for example, if you take analog signal, it will continuously varying like this. So if you assume that in x-axis, if you have the time, and a y-axis, if you have the value, so you will see that this will goes on like this. So you can say analog signals are continuous waveform. If you take temperature, light, sound, so everything, all these things actually, considered as analog signals. Now, what are the advantages? Now, one thing is you need less bandwidth. Now, bandwidth means number of, bits per second. We are going to talk about the measuring the data and also the transmit. So it will be very limited. The bandwidth, the amount of data that you need to transfer, the signal is very limited. We can say bandwidth is very limited. And also the accuracy is high, right? So what will happen when you transmit some data from one point to another point? Sometimes the data may get lost in between, right? There might be changes because when things are traveled from one point to another point. But if you compare with the digital signal, the accuracy in analog signal is very, very high. So that's why sometimes we convert digital to analog and then we'll transmit. And then at the end, we are going to again convert analog to digital. The second, if you look at the disadvantages, right, the cost involved in, the recording, the sounds in a tape will be really high. And then noise can distort the original. That means that it might change the signal, or there might be signal losses. And when there are errors, the errors are very minimal in analog, but errors is very difficult to correct. So there's no error correction, right? Now, the next one is the digital signals. Now, as the name says, in digital, you have two different states. So you can think this here. So this is the timeline, and this is the height. So you can say you have two levels, low and high, right? So it goes on in this level, suddenly it switches to higher level, again a lower level, again a higher level, again a lower level, and so on. So you know that computer works in this fashion. Computer works with these two states, and mathematically we represent them as 0 and 1, right? So basically computers uses digital signals. The advantages of digital signals are they are inexpensive, right? Compared to analog signal, comparatively it's inexpensive. Data could be encrypted, meaning nobody can read what is inside this digital signal. We can encrypt. Encrypt means you can, encryption means you can change the message so that those who are outsiders, they cannot, read the messages. So it's very important, especially when you want to transmit data. So privacy is reserved. Then the errors. I told you there could be errors, but in digital signals, errors can be easily corrected. So there are many ways of correcting digital signal, which we will discuss hopefully today. Then there are disadvantages. Again, you need like more bandwidth, you need more space, the data, amount of data to transmit the whatever the message. And synchronization, right? When you want to, merge or synchronize one into another, it will be difficult, right? Now that's about generally the two types of signals. Then we have discussed the properties of signals. Now, when you talk about the properties, when you mention about different types of signal, we usually talk about these properties of signals. So those are amplitude, which means the height, frequency, how many times a particular circle happens, then the wavelength and phase. So if we start with the amplitude, simply let's assume that this is the signal. I told you like it will vary with the time. So this axis you have a time, this axis you have the values. So values keep on increasing, then this is the maximum value, and then this is reaching the bottom minimum, and then you go in the other direction. So then this is the height from the center line to the top or a bottom point we call amplitude. It's the height of the waveform. Now then the frequency, how many times something could happen, we talk about the radio frequency sometimes, right? So this is measured in hertz. So how many waves pass a point in 1 second? So within a second, how many points passed, right? So assuming that this is a sine curve, the full sine curve is like this. You start from here and then you end here. So this is one full cycle. So how many cycles you can finish within a 1 second? So that's what we measure in frequency. So for that, we will use the unit called hertz. Then the wavelength. That means if you take the same adjacent point in the waveform, the total length of the waveform, the complete cycle, we call wavelength, right? So usually this is measured in meters. The last one we discuss is the phases. Now, when you take a signal, when you have two, signals here, you have two signals in two different colors. If you look at the same points in the two different signals, the difference, now here the topmost, point in, let's say waveform 1, this is the topmost point in waveform 2. This difference is called phase difference, right? Right. Okay. The next thing that we have discussed is the what kind of a media we can use from center to destination. If you have already done O levels, you have already learned this. So you can use wired media, meaning like you have a physical media to connect sender to receiver. We call guided or wired transmission media. Now for that, the popular usage is twisted pair, a pair of copper wires with a plastic cover is used as a wireless wired medium. Then coaxial cable, like TV cables you have seen, or in CCTV, usually you have coaxial cable. So coaxial cables are used as wired transmission media in wider applications. Then we will have fiber optics, so that is the fastest possible way of transmitting data from one point to another point. And fiber optic cables use light for the data transmission. Then we discuss wireless transmission media. We can use radio waves, especially in technologies like Wi-Fi and Bluetooth. Radio waves are used. Then satellite television transmission, we use microwaves. And for a very short distances like keyboards, mouse, and printers, we are using infrared. I think this is what we have discussed last time. Himanshu, POIT name the kata kare.
Oh, sir.
Right. Okay. So let's start. Today's topic. Then we are going to continue from here, and basically we are going to talk about um, what medium is actually used. We talk about guided media and unguided media. We talk about three things in under guided media, that is twisted pair, and also fiber optics and coaxial. Right. So when you talk about the coaxial, there are two bands. We will talk about broadband and baseband. So I will talk about this later on. And unguided media, we discuss radio waves, microwaves, and infrared. Okay. So that's exactly what we have discussed so far. Right. Right. Okay. So let's move on to the new, what we want to discuss basically wired and wireless medium that we have already discussed. So that part we have already discussed. Then what we want to discuss this part is latency, bandwidth, noise, attenuation, distortion. So how those affects the signal transmission. So let's start with the properties. So now, especially in data transmission, we want to discuss these signal properties. So in this here, what we are going to discuss is the properties of signal transmission media, right? So let's start. We talk about infrared good, and then yes, we'll start with the topic, right? So we can say, right, properties of
සර් සර් මේ ඒව කියලා දුන්නට ලිව්වේ නෑ ලියන්න ඕනේ නැද්ද?
ආපෝලියන්න ඕන කොයි ටිකද ලිව්වේ නැත්තේ?
guided wired transmission media ඉඳලාම ලිව්වේ නෑ.
මෙතන ඉඳන්
ඔව්.
ආනේ එහෙනම් පොතේ ලියාගමුද? නැත්නම් මම මේ වන්නද මේක පස්සේ ලියාගන්න ඉඩ තියෙමුද?
හා
කමන්නේ පැහැදිලි කරන්නේ මම මේ ටික පුතාලට දාන්නම් කොපි පේස්ට් එකක් දාන්නද මේකේ? ඔයාලට බලලා ලියාගන්න පුළුවන් නේ? මම WhatsApp එකට දැන් දාන්න කොපි පේස්ට් එකක් කමන්නේ දාන්නම්. දැන් අපි ලියා ගන්න නැතුවම අපි අලුත් කොටසකට යමු. කමන්නේ නේද? Let me put right. පුතේ මම WhatsApp එකේ දැම්මයි ටික පුතාලා හිමින් සැරේක ලියා ගන්න. අපි අද පටන් ගන්න එකට යමු. නෝට් එක අපි ලියන්න ඕනේ අලුතෙන් මේ අලුත් එක පටන් ගමු. Right, in this one, what we are going to discuss is properties of the transmission medium, right? Properties of signal transmission medium. So under this one, we are going to talk about a couple of things under properties. Now, the first one, we call it latency, then bandwidth, noise, attenuation, and distortion. Right, because we were talking about the transmission media, right? So let's start with the first one, right? Okay, so the first one we are going to discuss is called latency. Latency, or we can also say that it's the delay, right? We can use both terms here. So in latency, we can define as the time taken for a unit of data to travel from one point to another point. Simple idea. So remember, we discussed now in data transmission, we have sender, receiver, and then there's a medium. So the time taken for a unit of data to travel from one point to another point. So that's called latency. So to measure this one, we are using milliseconds, right? Usually the unit is used to measure latency is the unit which is used to measure latency is millisecond. Measured the unit which is measure latency is milliseconds. So we are using milliseconds or ms. Right. Next one. The second one we call bandwidth. The term we have discussed earlier. But let's discuss exactly what we mean by bandwidth. Right. Bandwidth is, we can say, a range of frequencies. We can say so we can talk about different bandwidths, right? But let's talk about the bandwidth in computing, right? So what we could say here, the maximum rate of data transfer, amount of data. So there are a couple of bandwidths are there. So we will talk about both of them. If we talk about the analog bandwidth means the range of frequencies that we could use. Right. So let's take down that. And digital bandwidth is something else, right? So that also I will discuss. So first, let's take down the analog one. Now, bandwidth in data communication, bandwidth is the range of frequencies, which accommodates in a transmission media, and measured in hertz. In computing, bandwidth is used to refer the amount of data transfer between two locations. So in computing, bandwidth is the amount of data transfer, um, let's say transfer across a given path. This is measured in bits per second. So there are other things like we have bits per second. Other measurements include kilobits per second, kilobits per second, then bits per second, and gigabits per second, right? So you can go on like this. But remember, when it comes to data communication, we say the range of frequencies. When you say range of frequencies, right? When you say range of frequencies, which means the lowest and the highest. Right. So that's about the bandwidth. Okay. So let's move to the next one. The next one is noise. Right? When you say a noise, now, for example, now we have when we have the discussion or when we have this online session, you know that my sound is the signal that you are expecting, isn't it? But there could be many more background noises are there, like, a dog can bark, for example, or maybe kids play, right? So that will be a noise. So noise means nothing but what uh, externally added to the signal, right? So what happened in a noise is it will disturb the original signal, right? And there are many noise types like thermal noise, induced noise, crosstalk noise, and so on. So that means different noise types are there, right? So let's take down those. So noise we can define it as yes. So the noise can affect the original signals, and there could be multiple types of noise is there. So we will sometimes call interferences. We call it, especially in electronics. We will say right. Let's write down about the noise. The data, or we can say the signal relevant to data is transmitted with the signal relevant to background. The signal relevant to data is transmitted with the signal relevant to background, or maybe we can say external. The signal which is not relevant is called noise. There are several types, such as thermal noise, induced noise, there are several types such as thermal, thermal noise, induced noise, crosstalk noise, and impulse noise. Right. So that's about the noise. So what is not relevant when you are sending a data? Sometimes you might send data which is not relevant to you. Right. So that's about the noise. Then talk about attenuation. Yeah. Latency we discuss, bandwidth we have discussed, noise, right? Then you have attenuation. So what happened at attenuation? So when you transmit a data to a very far away place, right? Very far away place, right? Then it will change the original signal. Right. Basically, attenuation means reduction of strength. The reduction of signal strength. The reduction of signal rings we call attenuation. So when there's no attenuation, it's fixed, which means the energy is the same. There's no change of the amplitude. But when there's attenuation, you will see, right? The strength will get reduced over the time. Right? For the time, it'll reduces the amplitude. Now, if you want to avoid this one, usually what will happen, right? We need to have other device to prevent. So we can write down, you can draw this, and then you can write down to prevent attenuation. Amplifiers can be used, right? Amplifiers. Amplify means it's enlarge the signal, right? So when the signal gets smaller, we can enlarge it, right? Or we can increase, so we can say amplify the signal. Right. So that's what we call attenuation. So when the particular signal travel through the medium, the energy of the signal reduces. This is known as attenuation. So if you want to prevent this attenuation, then you should use amplifiers. Okay, let's move to the last one, last property. Now that's called distortion. Right? It's called distortion. Okay, let's move to the last one. Now, when a waveform travels through some media, when you transmit a particular message from one point to another, the shape of the signal, right, or else the original shape of the signal may change. So this is called distortion, right? So the damaged data or the change in the original shape, right? When the message through the transmission media, we call distortion. So simply the distortion means when you have a travel, right? We can say the original signal, or we can say properties of, we can say the properties of the original signal may change during the transmission due to capacitors and inductance, the communication medium. There are different reasons. Capacitor, you know, in capacitor, and also the inductance. So these are the inductance. It should be inductance. Yeah. So due to inductance, uh, so that may change the original shape. Original signal may change. It might change the shape. So the shape might vary. So this is called distortion. This is called distortion. Distortion, right? So let me show you this in another figure. So let's first start with the digital signal. Right. So let me show you a figure for this. So let's say this is a digital signal. We know high and low, sphere-shaped one. But when you receive, you might not receive like this because the noises added, there are issues with the capacitor and inductors. So it's slightly vary like this. So this is called distortion. So the shape of the signal may change during the transmission. So when you input, digital signal like this, but when you receive, right at the end, you might get it something like this. So basically what you have to do is you have to change this. What right now, so that's the last one we call distortion. Right? The signal shape is actually might change. So let's quickly review what we have done so far. So this is the properties of signal transmission media. First of all is latency. That means time it takes to travel a unit of data from one point to another point, which we call the latency, and it is measured in milliseconds. The bandwidth, that means the range of frequencies that you can have. That means the lowest one and the maximum, right? Low and high. Uh, and this is measured in hertz. The noises, when you send signals from one point to another one, there are some additional background noises and some, right? Background comes. So this is called noise. And the next we call attenuation. So when signal travels through a medium, the energy of the signal or signal strength, right, reduces, and this reduction we call attenuation. And the distortion means the shape of the signal may change when you transmit signal one point to another, right? And this is called distortion. Okay. Now, the other one that we want to discuss under this is we call simple topology. The idea that we want to discuss is point-to-point connection. What do you mean by point-to-point connection? Means you connect two devices, right, using a single cable, right? So topologies we will discuss later on, like there are many ways that you can actually connect computers together to especially form network. But let's say to, connect, simplest network, like you want to connect two computers together, you can use point-to-point, connections. So let's take down that also under another point. Hmm. So we will call simple topology, right? Now here's simple topology means simply you are connecting one computer to another, or maybe it could be a one switch to another switch, or a computer to a switch. And for that, we can use a single cable. Right. So that also we write a simple topology. Or this is also called point to point connection. Right? Point-to-point connection. So when you say point-to-point connection, like connecting two devices, connecting two devices such as computer, hub, switch, hub, switch, routers, using a single cable is known as point-to-point connection. And this is the simplest topology you can have. Okay. So this is also that we want to discuss as under this. It's not very relevant here, but in the syllabus, it was mentioned like this. So point-to-point connection, connecting two computers together. So multi-point, we are not going to discuss, but simply you can draw two computers and you can say it's point-to-point connection. Right? So multi-point connections we can discuss later on. For the time being, let's draw two computers and then we can connect a link. So it could be a single cable, like in computing, you can purchase what we call cross cable. Using a cross cable, you can transfer data between two computers. Right. With that one, we finished uh, the properties of simple data communication, especially when you want to talk about the details, signal transmission media. Now we'll switch to um, 6.3. Basically, we are going to look at different levels, voltage levels, and then we will also discuss the change of frequencies and phases in signals. And then we will also discuss synchronization. Remember, I told you like synchronization problem in digital signals, and we are going to discuss why. And then error corrections. I told you like when you transmit data, the data may be distorted, right? How can we correct any errors, right? Okay, so under this one, the first thing that we need to discuss is how do you connect two computers together. in a data communication. Now for that, we need to have a set of rules, a protocol, and then you have to have like different levels of voltages, that amplitude, and then also like there are changes in frequency and phases. Okay. And then we will talk about the change of speed of elements, and then timing. Clocks are used for synchronization, and then handling errors. Right. Right. Let's write down. I will go to new page. So this one, what I'm going to discuss is right. Uh, let's write down the title: data encoding using signal elements. So let's discuss what this encoding means. I'll come to that point. So under this one, as I told you earlier, we will discuss how we may use different ways of what we call modulation. We are going to talk about here the term modulation. So now we already know now the data transmission happened in two locations. So we said we have a sender and a receiver, and then there should be a wave to transmit data. We call it carrier wave, right? Remember, I told you, like when you want to send data from one point to another point, there should be a signal going on, and we know that some signals it will distort, and some this will attenuate, right? So because of that, we are using what we call the carrier wave. So the carrier wave is used to carry the data, right? So the data usually you have in a electronic wave, and the electronic wave we have to put into the transmission media, right, to transmit it, right? Now for that, the data we have to connect with what we call the carrier wave, right? And the carrier wave, you have to have high frequency, amplitude and the shift, right? For this combination, we call it modulation. The term modulation comes in there, right? So modulation means your original data is converted, or you combine with carrier wave to send data. So that's what exactly what we are going to do, right? So basically what will happen, there will be a two signals we are going to combine together, right? So this is exactly what will happen. So there are various ways we can do this, right? We will call it amplitude modulation, right? Amplitude modulation means we will use amplitude, the height of the wave we are use there. Then frequency modulation, the frequencies are used for the modulation, right? Frequency modulation, frequencies you use there. Then we are using a phase modulation, the change of phases. You remember we talk about the phases there, right? So we will use different phases for this, right? So let's define the term modulation first. So we'll start with the term modulation. So in simply, modulation is use the original signal that you want to send with a high frequency signal, which is we call modulated signal, right? Okay, let's write down. To send data from one point to another, we want to send data from one point to another. So we need to send data from one point to another. That means our original signal, we have to combine with a carrier signal. Right? The signal, so we have some what we call modulated signal. Attached with a higher frequency signal. Higher frequency. To send data from one point to another. The signal we call the modulated signal attached with a higher frequency signal. That means we are going to combine two signals together. Simply you can say, we can say carrier signal. So that means our original data is here, but you can't send this because remember we talk about uh, there are distortions, there are attenuation, like the energy will be reduced, right? And then the change of shapes are happening now. Because of that, we attach with another signal together. So we are trying to mix two signals together. So that's exactly what we call modulation. By modifying by modifying frequency, amplitude, and phase. So we can, to combine two signals together, we can use frequencies, you can use amplitudes and the phases, right? So let's start the first one. We'll start with amplitude modulation. Amplitude means we are taking the heights, right? We are taking heights of uh, the signal. And then we, by combining, we get a signal with a higher frequency with the shape. So under this modulation, we will talk about, right, amplitude modulation, amplitude modulation. In short, we will call AM. So amplitude modulation, I told you, you combine two signals together by changing the amplitudes. I told you the combination by happening modifying frequency, amplitude, and phase. So amplitude modulation, it will change only the amplitude, but not frequency and phases. So that's exactly uh, we have to take down and amplitude modulation. So we can say amplitude, that means height of, let's see, of carrier signal varies according to the amplitude of the modulating. The frequency and phase of the carrier signal remains unchanged. So other two properties will not change. We are changing only the amplitude. Right. Let's discuss this with a simple diagram. So in this one, what we are going to see is Right. In this one, I'm going to see combination. So this is message signal means our modulating signal, right? So this is a modulating signal. And then this is low frequent. Low frequent means number of cycles per second. Let's say this is 1 second. So you have only 2 cycles. So here we have a higher frequent one. So what will happen uh, is you combine these two. So message signal, or we can say it's the modulating signal. So this height of these two uh, combined together. Heights are combined together. The resulting signal looks like this. So in this particular case, what you see here is the frequency will be the same. And this is the carrier signal. So there's no change for frequency and there's no change for phase. Yeah, there's no change. It will be the same. Start and end will be the same. But the heights are different, right? I told you amplitude modulation means you combine these two together. And what you get is the amplitude modulated signal. Okay. So can you take down this one? So the first one we call message signal, or you can also say modulating signal. So this is exactly what I have used the term. The properties of the signal. So we want to know three things when it comes to modulation, that is amplitude, frequency, and the phase modulation. Now, first of all, amplitude means the heights. So you will see the heights of the signal may vary, right? So by varying the heights, we will have amplitude modulation. Then we have frequencies, the number of cycles per given time, let's say second. So the first one we have 60 cycles, so here we have 30 cycles. So that means this is higher frequency, this is lower frequency, right? And then we will have phases. Phases mean the shift, right? Now if you take the upper point here, so the shift, and this is known as phase difference. So in the modulation, we can make use of these three. We can use of amplitude modulation, frequency modulation, and then phase modulation. So we can make use of three. So what we have just discussed is amplitude modulation. Now, if you talk about the advantages of this, right? Why, amplitude modification? It's easy. So first of all, advantages. Let's take down the advantages. If you look at advantages, so let's start with advantages first. So if you look at the advantages, so this is easy, right? So you can say modulation is easy. Modulation is easy. So modulation is easy. And once you do this, right, at the end, Now this is what will happen in the sending point. When you before send, you combine these signals together. And in the receiving point, you have to demodularize so that you will get the original signal, right? Demodularization is modulation. Modulation can be done using a simple circuit. The problems may affected by may be affected by external noises. So sometimes, so that might be an issue. Right. So that's about amplitude modulation. So the second one, we can talk about frequency modulation, frequency modulation, or we will call FM. Right. Frequency modulation, as the name says, what will happen? We modulate using the frequencies. Right. Let's write down. Vary the frequency of the carrier signal according to the modulated according to the modulating signal. So you change the frequency, then amplitude and phase will not be changed. When voltage the modulating signal is low, then when the voltage of the modulating signal is low, then the output contains low frequencies, whereas volt whereas whereas voltage modulating signal is high, when the when voltage of modulating signal is low, when output contains low frequencies. Whereas voltage of the modulating signal is high, then the output contains high frequencies, right? So let me have another figure like the same. So we can say that, yes, in frequency modulation, so frequency modulation, so this is the original signal, the message signal that we want to pass, and this is a carrier signal, it's a high frequent one. So there's no change for the amplitude, it will be same in the resulting one, but you will see the frequencies were changed. When the value is low, then the frequency is also low. When the value is high, frequency is also high. And this is called frequency modulation. Frequency modulation. So you see here, you have a high value, so you have high frequencies. Here we have a low value, so you have a low frequencies, again high, again low. Frequency modulation, what we send here is we change the frequencies. So this is the original signal that we want to send. We are not going to directly send this because otherwise, there's attenuation. The signal strength will, it will reduce the signal's energy. So what we do is we combine with the, high frequency signal. So this is known as a carrier signal. So when you combine, we will get a signal like this. So what you can notice is when you have a um, the signal value is high, it's high frequency. When a signal value is low, then it's low frequent, right? Again, when it's high, you you have high frequency, and when you low, you have low frequency. So you see that amplitude won't change, it will be the same, right? So no change of amplitude, no change of phases, right? The next thing that we are going to discuss is phase modulation. So let's take down advantages and disadvantages before we move any further, right? So let's look at advantages and disadvantages of, right? So the advantages of frequency modulation, right? So advantages are like this. So in this particular case, um, the effect of noise. You know that when you transmit a signal, there could be outside noises may connect, uh, is reduced. But if you're using frequency modulation, this effect is very minimal. Ability to transmit clear sound. Right. Then disadvantages. The circuits used for modulation and demodulation is very complex. So the circuits that we need to use is, they will be very complex. High cost for modulation and demodulation. Right. So these are the uh, advantages and disadvantages. So the noise effect is reduced compared to other modulations. So you can clear sounds you can transmit in this method, frequency modulation, FM. And then circuits used for modulation and demodulation is very complex. Yes, that's one of the disadvantages. And because of that, you have to spend high cost for modulation and demodulation. Right. Now we discuss frequency modulation. Let's talk about phase modulation. So the third one that we are going to discuss is called phase. So we are going to change phase, but not the other two. We call phase modulation, or in short, we will call PM. Yes, phase modulation. Right. In phase modulation, like in two previous cases, the first one we discuss amplitude modification. So that means height of the signal has changed. When you combine the message signal with the carrier signal, here the frequency has changed. Likewise, phase modulation, we change the phases, right? The changes of the modulating signal reflected by the changes of modulating signal changes, then it should be R, right? This of modulated signal are reflected by using phases, right? By using change of phases, the amplitude and frequency will not be changed. Will not be changed. This is we call phase modulation. So this is what will happen here, right? So this is the original signal. Oh, we want to send this, and this is the carrier signal, and the phases are changed, right? So these phases have changed. You see the phases have changed. So it's no more in same direction. The phases have changed to reflect the message signal using phase modulation, right? That means when there's a high voltage, you see there's a different pattern, and the low voltage, again, there's a different pattern like this, right? So this is called phase modulation. Okay. Right. When you finish it, please let me know. When you finish, please let me know in the chat.